enable it just to detect the nature of the attack at that point in time. And it has seemed to work in the past. Because that's where you really try to find the SQL injection kind of attacks, or if there's a malicious backdoor stored procedure which we've run across in the past, which was not as easy to detect.
Got a question over there?
Yes.
Not for C2 auditing.
No.
No. Oracle, I believe, has some of those kind of things where you can send stuff to the operating system log that then can get sent to the syslog to other places. But
no, it does not actually. It does log it specifically to the same directory where your SQL server is resident. Actually, so before I pass that on, okay, I guess it's Chuck's turn again to speak.
Yeah, I'll just talk real quick about Oracle. I mean, it's basically, by default, it's the same kind of things you see in Microsoft SQL. It's logging when the database starts, when it stops, and connections to the database, which in a web application is just going to be basically connections by the application, whatever usually the application is running as. You'll also see DBAs connecting. But by default, that doesn't tell you very much useful. But it does have the ability, you can audit some additional events, either to a table in the database itself, which is handy because then you can run SQL queries on it and whatnot, or you can send it to the operating system log, which then can get redirected with syslog to another system or wherever. And those events, so the top events here are what's called mandatory auditing that you really don't have any control over in Oracle. And then the bottom is just kind of the Oracle auditing, they call it sometimes, or I call it additional auditing of other things. And you can do table level access in the Oracle auditing, but you can't get down to like row level access that you can audit. And just a quick terminology, and I don't want to belabor the point, but I think it's important for you to know kind of what this means. Is Oracle calls all this stuff auditing, where in reality it's not auditing, it's really logging. But logging in Oracle means something entirely different. Oracle logging is basically how Oracle kind of checkpoints the database to be able to restore from a crash. So if you're talking about Oracle logging to Oracle DBAs, then that's what they're talking about. This is auditing that they're talking about here. And then you also run into, in addition to auditing, it's got alerting, which is, at least that's what I call it. It's the alert.log file, which basically is going to record some database type operations as far as if there's errors in stored procedures, if there's references to things that don't exist, that kind of thing. And it also will have trace files and dump files that it basically, the main alert.log will point to these other files. So that can definitely be useful, just like the Microsoft SQL error log can be useful in finding like SQL injection attacks especially, because SQL injection attacks typically, it takes a while before the attacker quite gets it right. So he causes a lot of SQL Server errors in the interim. So that's just a quick down and dirty on Oracle auditing. We got 15 minutes left, so I'm going to run quickly into application level logging. And I don't want to run through this too quick because I think this is very important. And if we had a room full of developers, we'd spend a lot more time on this. But in general, the application is the best place for the logging to happen. The application knows the business logic of what's going on. It knows what users are associated with what sessions, all that kind of stuff. So good application logs have a very good signal to noise ratio in as far as telling you exactly what's going on in the application and potentially where there are problems. So when you come into a web application incident, you want to ask the developers or the administrators, hopefully you can talk to both of them, is where does it log this data and what kind of format does it send it in? Is it a text file or is it going back to the OS log or what? And what kind of messages are you going to see in those logs as far as things when you start doing your greps through the logs, what to look for? And also it's important to know how long they're stored because they may be overwritten pretty quickly, so you want to make sure you grab them right away. So application level logging is great when it's there, but it's hardly ever there, is the unfortunate reality. But a good application is going to log these kind of things. The main thing is going to be invalid input. It's basically if web application developers spend a lot of time dealing with input validation, and you're basically detecting cross-site scripting and the SQL injection type attacks. So anytime that those rules are violated, that someone's trying to do something they shouldn't, then that should be logged. And then also just other kind of things, failed authentications, which could be, password brute forcing. Any sort of authorization and session type issues should also be logged. So basically, whenever there's any sort of error within the application logic, that should get written off somewhere. And other, critical stuff, just even successful things within the application logic may want to be logged. So that's a quick kind of what it should be. And this is just the kind of data that you want to record for it if you can. That's pretty self-explanatory. And if there are any developers here, there are some great logging frameworks available that really make logging very simple. Because a lot of times the reason that it doesn't get built into applications is because it's a lot of work to write it all from scratch, and it's hard to get it consistent and all that. But use Log4j or Log4net or Log4PL/SQL or one of the other kind of things that are listed there. It really makes it easy to build your logging into your application and also configure it on the fly, that while the application is running, you can actually change the level of logging that's being done. So when you think there's an incident, you ratchet the logging up. Then when it's running normally, then you can ratchet it back down. So that's pretty cool. And now we kind of just get to the end. So we've gotten to the point where we've basically kind of traversed back through our application, starting at the web server back to the actual application itself. And now we hopefully we know what happened. We have some idea of how the attacker came in, what kind of data they may have taken, that kind of thing. So now we want to know really what are we going to do about it. So I guess really the first decision is we started this talk talking about the regular incident response and forensics processes, and there may be occasions when in a web application attack you need to go back to those, that once you've done all these application level things and you realize, hey, I can see that he attacked the Microsoft SQL server database, and then he used XP command shell to then run these other processes within the operating system. Well, now you're back to more of a traditional incident response methodology where you need to be looking for hidden processes or other extraneous processes that are running, network ports that are open, all that kind of stuff. So that's definitely a decision to be made. And then you also want to kind of just decide how you're going to fix it. You've got this problem. Now you want to, well, if you've got enough data to know exactly what happened, then you may be able to just kind of basically back out the changes that were made by the attacker in the database, if there were any, and kind of basically get back running from where you are. In many cases, you're going to have to go back to a backup and restore from that, and then try to pull over the legitimate transactions from the newer system. And sometimes you've got to just rebuild the whole thing from scratch, which is no fun, but sometimes it's just what you got to do, especially if you don't know how long the intrusion has been in there. A lot of times your backup tapes might be corrupted.
Right, and also sometimes you'll run into applications which are, for example, partly classic ASP and the rest of it is ASP.NET, and you have all the classic ASP stuff vulnerable to things which are by default taken care of by ASP.NET for the most part. So that's when it's time to call the shots and move everything over to .NET probably.
And obviously, if you're restoring from backup or building from scratch, you want to make sure you fix whatever vulnerability the application had before you put it online. Otherwise, you're going to be back right where you started. So I think that's obvious. But yeah, go ahead.
You should think about this stuff before there's an incident.
Oh, definitely. Oh, definitely. I mean, unfortunately, we do get called in to do application security assessments and that kind of thing where we do that. But typically, by the time we get involved, it's kind of too late. But yeah, there's definitely a lot of things you can do in the building of and fielding of the application to make it much easier on the people that are going to respond if there is an incident. I think Rohit and I were talking earlier. It's kind of the old saying: if you fail to plan, you plan to fail. Where you need to plan what's going to happen if there is an incident, so that you've got the stuff in place.
It's a typical military statement coming from a guy like that. Fail to plan, plan to fail. Or I heard another one:
yes.
Your 50% operational capability or something of that sort. But I guess what Chuck is trying to put across is exactly the point the gentleman said there, is you want to think about these things well in advance. It's not after the fact. These should be incorporated into your SDLC, the logging, thinking about potential forensics, because you can do everything right, just the one hole is what an attacker needs.
Yep.
So
and really just this kind of just talked about what we were talking about earlier, that you need to be familiar with how applications work and how to update your checklists and that. I see everyone leaving, just remember we've got something to give away. So hopefully whoever we draw is here, because you must be present to win. We should have mentioned that earlier. So anyway, in conclusion, there's really nothing else. So this is us, as we mentioned earlier. Thank you.